All right, guys, so just a quick recap of what we did yesterday. So remember, we were doing two-step equations where you had to do two different inverse operations to isolate your variable. Now remember, we're doing the order of operations backwards, which meant that we were dealing with our addition and subtraction first, and then going in and dealing with our multiplication and or division, okay? So we stopped at number 3. We're going to take a look at number 4, 5, and 6 real quick in this video. So if you look at number 4, there are two things happening on the side with the x. It may seem a little weird, but this fraction and x are actually being multiplied. So what we're doing, and I know it's a little weird, so we're multiplying by 2/5, and then if you notice, we have minus 9, which means we are subtracting 9. Now, we need to get rid of this 9 first, so we're actually going to add it. So the inverse of our subtraction is addition. So we're going to have 2/5 x equals 30. Now, if you notice, we are not multiplying by just one number here. We are multiplying by a fraction. So we're going to handle this a little different. So the inverse of this, all right, is to multiply by reciprocal. Now, you may remember the reciprocal a long time ago. The reciprocal is basically your fraction flipped, okay? So in this case, that would be 5/2, okay? So the inverse of multiplying by 2/5 is actually multiplying by its reciprocal, which is 5/2. So I'm going to multiply both sides by 5/2, and I'm going to show you why this works. So I'm going to multiply my fractions across, so 5 times 2 is 10, and then 2 times 5 is also 10. Now, this 30 technically could be written as 30/1, because anything divided by 1 is still the same value. So I can do that and just to make it where it looks like a fraction. Then I'm going to multiply across, so I got 30 times 5, which is 150. Don't be scared by these big numbers, it's all right. And then 1 times 2, which is 2. So now that I've multiplied, you'll notice on the left side here I have 10 divided by 10. Now the thing is, 10 divided by 10 is 1. Like if I had 10 cookies and 10 people, each person would get 1 cookie. So this will be 1x. So just x by itself. Then if I actually divide this, and guys, there is no harm in going to the side and actually dividing this. Okay, if you do that, you'll get that it goes into 15 7 times, which would be 14. We'll bring down the 0. 2 can go into 10 5 times, which would give you 10. So when I divide, I get 75. Now, there is another way to look at this, guys. I would suggest going through it by multiplying by the reciprocal. In my opinion, that will be the easiest way to do this. If you are having trouble with this, I can show you the other method, but I do not want to confuse you with a whole bunch of different ways. Okay, so again, if you're multiplying by a fraction like this, you are going to multiply by the reciprocal, which is just the fraction flipped. Okay, all right. So now if we look, number 5 is a little different than the ones we've done with fractions before. Okay, you notice how x is not alone in this numerator here? So this right here is one of our exceptions. So how I told you guys we'd always do addition and subtraction first and then multiplication and division, this one is an exception. So x is not alone in the numerator. So if you have a fraction where the x is not by itself in any part of the fraction, then that's the exception for what order to do things in. So technically, we have two things happening. We have adding 4, and we have dividing by 3. All right, now, because this is attached to x in the numerator, these are like basically together. We cannot split these apart until we deal with the fraction. Okay, so we have to deal with the fraction first. So that means we want to do this division first. Okay, so again, these are stuck together until we get rid of the fraction. So instead of dividing by 3, I'm going to multiply by 3, so the inverse. When I do that, these 3's will cancel each other out. I'll be left with x plus 4 equals 33. And now that the fraction is gone, I can split up the x and the 4. So now I can subtract by 4. Now, remember, you can check your answers. So like this one in particular might be one that if you did it on your own, you might be concerned about if you did it right. Remember, you can always check your work. So if you decide to check this, you're going to take your equation, x plus 4 all divided by 3 equals 11. You're going to substitute in 29 for x. And then you are going to simplify. 29 plus 4 is 33. 33 divided by 3 is 11. And then we get that 11 is 11, which is true. It will always be true. So if you get a true statement when you substitute a value in, that means that they actually are equal to each other. So the left and the right side are in fact equal, which means that we did it correctly. All right. So then we have our last question here, number 6. Remember, if you do not see a number in front of x, there is automatically an imaginary 1 there. So it may be a good idea to write that 1 in. In general, you can always write that 1 in. This one is something special, and that's why I want to make sure we have that. I also want to make sure you think about that this 8 right here is actually a positive 8. So because it's written before the x, I'm going to put a sign on it just so we remember that it's positive. So really, I need to figure out how to move this 8 away from the x. Since it's a positive 8, we're going to do the inverse, which is a negative 8. So I'll have negative 1x equals negative 7, because 1 minus 8 is negative 7. And I want to make sure you realize that these pieces right here have to come down together. This negative is attached to this x. It has to go with it. So right now, this negative 1 and x are being multiplied, because we don't see a sign in between them. So we're going to divide both sides by negative 1 and get that x is 7. Now, there is another way to think through this. In this step right here, so where we have negative x equals negative 7, and you could have brought that 1 down or not, this means the opposite of x is negative 7. So if the opposite of x is negative 7, that would tell me that x itself is 7. It's the same thing as dividing by this negative 1. It's just a different way to think about it, depending on how you decide to go through it. All right, guys.